Hey everyone, I know it's been a while, life and all that. If you haven't seen my previous videos, I'm something of a masochist seeking to design an ultra low drag top speed RC car, hopefully using with some active aerodynamics. If you've seen the earlier versions of this car, you'll know that I was attempting to use a rear steer setup. Where the tail would actually work like a rudder and actually move that rear wheel. It worked great at low speeds, but man, somewhere around 25 to 50 miles per hour, it was just a complete nightmare, and the car would spin out and crash. After about 50 mile an hour, the aerodynamics of the car basically took over, and the car started acting like an arrow and would start driving straight, and the rear end was just basically along for the ride. After all these troubles, I decided just to go ahead and scrap the rear steering completely and try differential steering. This is the same concept they use to steer tanks and some robots. By using two separate drive motors, one attached to each of the front wheels, I can control the torque output of each front wheel independently, thus actually steering the car without any mechanical linkages of any kind. So with differential steering, you can't really influence the steering very much just by varying the torque. So it's going to have an enormous turning radius. But I figured for this kind of car, it's probably an advantage not to be able to actually steer the car very much. I just needed to go in a straight line. On paper, implementing differential steering sounded really simple, but over the last 6 months, I've found that packaging two motors, active aero, and all the electronics into a small streamlined body was anything but simple. My original plan was actually to mount one motor in front of the axle and one behind the axle and transmitting the torque through a set of gears. But with differential steering, I have basically a split axle now in the front instead of one solid axle. So I can't use that solid front axle as kind of a stress member to stiffen the wings and the monocoque anymore. So the chassis, no matter what I do, is going to flex more. And unfortunately, gears don't like that kind of twisting misalignment. So I went ahead and switched to a GT2 drive belt. The belts tolerate twisting misalignment much better. They're not going to have any issues with that, for a small amount at least. And for packaging it, it made it a lot easier because now I can actually just make the rear motor be further back and just have a longer belt so that I can actually package all of the electronics for the active aero, as well as just getting that motor out of the way of some of the structure that I needed to add to the monocoque. Now, of course, changing the drive layout and adding a second motor meant that I needed to rethink all of the electronics in the car. The tiny ESP32 I was using prior just doesn't have enough outputs to control two ESCs while connected to a GPS and a 9-axis IMU. So I went with a larger ESP32 dev board, which the other issue I had, unfortunately, once I designed this whole new monocoque to try to fit everything, was once I wired everything up, I realized I hadn't accounted for the additional space for all of the wiring going to this new microcontroller, as well as the two ESCs now required to run the motors. And all of the wires were touching the motors because the electronics were up in the front. So since this was a prototype, I just pulled out the active aero servo to try to give myself a little bit more room around the actual motor wires and the IMU. And then I added this nice black 4-inch long extension tube to the body. And as a bonus, it actually ended up shifting the weight a little bit more rearwards. So it's not quite as front heavy. So it's about 70% front and 30% rear, which I'm hoping is going to be a little bit more stable than some of the last iterations of the three-wheeler. Since I had to redesign the body and the monocoque anyways, I took that opportunity to make some aerodynamic improvements using AirShaper's cloud-based CFD service, along with some of my simulation data that I had kind of built in my spreadsheet. I had figured that I basically needed more downforce on the car so that I could accelerate faster. And this is primarily because I live at roughly 7,000 foot in altitude, or 2,100 meters. And the air density is about 20% lower than it is at sea level. And that means that the car consequently generates about 20% less downforce and 20% less drag than it would at a lower altitude. So to compensate for that and to help the steering of the car a little bit, I actually stretched the wings so that the front wheelbase was a little bit wider. Actually, it's about 20 millimeters wider. and I actually increased the angle of attack on the front wings by about, I think, 1.5 degrees. That gave me that grip that I needed in the thinner air to hopefully maximize my acceleration. It also meant I could run much larger flaps, so they're wider in width, which generate much more downforce at low speeds, which is great. And with the flaps completely vertical, I go from tripling the car's drag at 200 mile an hour to actually increasing at 5x, which is going to significantly shorten the braking distances. And if I ever run the car at sea level, I can obviously just back off the wing or even go with a less aggressive airfoil, and I can get the drag and all that back to where it was before. But it's still really impressive. I think I have a coefficient of drag just over 0.2, which is great for a car this scale. But as you can see here in AirShaper, these larger flaps, along with the increased angle of attack, introduced a new challenge for the car. With the flaps at about 30 degrees, which they would be at low speeds, the vortices coming off the wings are significantly larger. In fact, the vortices themselves are large enough to create some lift further back on the car's monocoque and the tail itself. And then you can actually see in this picture under braking where the flaps are completely vertical, the vortices are absolutely massive, which is great. It's creating a lot of drag and slowing the car down, but it's also creating about 60 grams of lift at the rear of the car now. So this brings me to something that came up in the comments from the last video. A lot of people wanted me to try a T-tail on the rear, basically raising the rear horizontal stabilizers up to the top of the tail. The reason I didn't try this originally was the less aggressive wings didn't create these large vortices, and I was able to actually keep the horizontal stabilizers lower on the car and on the tail, which helped to reduce drag, and they were in ground effect, and it just helped the downforce and everything. But now you can actually see why CFD is so important, because with this new design, this approach of having these horizontal stabilizers down low is going to potentially cause some instability under braking. So down the road, I'm going to have to take a performance hit and design, in fact, a pretty tall T-tail to try to get that horizontal stabilizer higher up into the airstream. Another area that I had to make some changes that I kind of alluded to earlier was that I had a lot more flex in the chassis because of that front split axle and the larger wings themselves. Without any additional support, the existing monocoque design would actually hit the ground when you go over a bump. So I went through several iterations, adding structure to the monocoque to try to stiffen it up. And for no real reason other than my engineering OCD kicking in, I also, for some reason, decided to change the entire body and take out 150 grams from the total car. What I actually ended up doing was running 2 reinforcement, basically filled areas down the bottom of the body. So this helps to decrease flex. The other thing I did to address the flexing of the monocoque was to add this bulkhead to the body. This basically ties the wings together using some of basically the existing bosses that I had already built into the monocoque for the wheel bearings that are on the inside for the front axles. But when I was doing this, I also realized that some flex was not entirely bad. Since the car doesn't have any suspension, a little bit of chassis compliance could help out a lot to ride out the bumps more smoothly and hopefully make it more stable at speed. So it's pretty easy to see how much of a pain this RC car is to assemble. Everything bolts together. It's got to be slid together in just the right order. All the wires have to be tucked. But it's the price we have to pay for the packaging, obviously. I mean, overall, the system actually works pretty well, and it's not terrible. It's extremely lightweight, and actually very strong. Okay, so ready for the first run. Let's see if this thing can actually go anywhere. And you can see it goes pretty well. It has a little issues with going left or right. It obviously actually runs better in reverse right now than it does going forward, but it just doesn't have any brakes going in reverse. I had a little boo-boo there trying to stop the car, but other than that, it does go. The biggest issue we have is really trying to tune in the steering, because I think we're getting some very definite belt slippage. Now, the other disadvantage, as I had already talked about, is the absolutely enormous turning radius. I think it's about at least 25 meters. So getting it to come back to you is almost impossible. It's a back and forth type of a deal to try to get it to do it. Or you've got to end up driving in reverse back towards you, which again, actually reverse works pretty well. Minus you can't actually steer very well. Just barely steers. Like that's full steer. Yeah, this time I actually try to turn it all the way around, and as you can see, I just keep going back and forth about 3 times before I can actually get it to come back at me. Just barely turn. There we go, finally. So I'm really not setting any speed records at this point. I'm still having the pulley slip. If I use too much acceleration, I basically just dig the pulleys into the axle and I spin them around, and I've got to reseat the pulley onto the axle because it's just too much torque, I think, for these small 5mm diameter axles that I'm trying to use. So I tighten everything back up and we try one more time. And pretty much immediately you can see the one belt is slipping. That's why it tries to pull to one side or the other. It's actually kind of a terrible failure mode with differential steering, is because if either of the two motors fail or if there's any slippage in the drive, you basically have the car try to steer one way or the other. So it can cause a real mess. Which one's loose? It's you again. First of all, I just don't like the failure mode, as I mentioned. If one axle starts to slip, the car will just steer and careen into something. I need to actually probably upsize the axles. I'm using a 5mm axle. I probably need to go to at least an 8mm axle. The reality is the torque is just too much, and you're trying to grip onto something so small that the set screws are just tearing right through the aluminum. My plan is to obviously make some redesign changes, increase the size of the axles. I also want to potentially add an idler pulley to the actual belts themselves. The rear belt in particular is being longer. I'm just not getting enough belt wrap around the pulley so that I can get enough traction for the amount of torque. It's much better than the rear steer. Just having the axles separate, not having a solid axle, just allows it to go over bumps a lot better. The solid axle would cause it to pull one way or the other a lot more. Honestly, it does run better in reverse when I have the split axle like that. And so I am tempted to try running it in reverse as well and see if whether or not I can make some aerodynamic changes to make the car run in reverse okay. I also have a couple of other designs that are more simplistic, more traditional, like all-wheel drive type setups, basically variants of the RC hypercar except smaller, that would be a lot more stable and a lot easier to package and manipulate so that I can essentially get testing. I need something that I can get a lot of runs and repetition into, if for nothing else, to start having something to model the software and the data for this particular type of RC car with. So again, I'm sorry this is a bit of a disappointing video, but it did highlight a few things. First of all, that I'm going to have to play a lot with the aerodynamics, and that small changes can have big consequences with the aerodynamics, and that the differential steering is a little bit harder than I thought it was going to initially be. So that wraps it up for this video. Hopefully I'll have another video out here soon.